Alright, welcome to part 2 of our video on addressing modes. Last time we covered the immediate, direct, and extended addressing modes, and this time we're going to cover these modes here. So these are the indexed and the stack pointer addressing modes, of which there are a couple of each. Now before we go any further, I want to say this is going to tie in very closely to the C-style pointer, and if you didn't understand pointers, I think this is a useful second way to come at the idea. So this is going to help us do things of this form, where x is equal to x plus zi, where we didn't know this I. This I is not something we knew at the time we wrote the program. Instead, it's something that's going to come up based on the program's state. This could be used inside of a for loop, but a for loop you might know at compile time. You could technically go and write separate instructions for hitting each element in an array. But instead, if we think maybe we're doing something like what's called a lookup table, where this element I comes from an analog to digital converter, or it comes from a switch bank. It comes from the outside world. In these cases, we can't know I when the program is being written. The assembler doesn't know what I is going to be, and none of the addressing modes we've talked about could possibly work. So I'm going to focus the discussion a little bit, and we're going to talk primarily here about this indexed addressing form. And this indexed addressing form relies on a couple of registers that we haven't discussed yet in this class. One is the H and the other is the X register, and they're both 8-bit registers. In older versions of the SO8, there was only an X register. In all of the newer, more modern versions of the SO8, there's also an H register. And the way that this is going to work is it's going to work by holding the address of what it is that we want to go grab. For example, if we put in here, we put a 0150, and then we were to run an index mode command. That is, let's say, the add with carry index mode, which is object code F9. If we run that command, what it's going to do is it's going to look out to the HX register and say, okay, the HX pair is telling me that I'm looking at hex 0150, where this is by the way in assembly, that's how you write hex. In class so far we've been saying 0x, but in the assembler you'll see me occasionally use a $sign here. It knows that this address is the one where we wish to look in order to find the value of interest. So we're going to add with carry some value. We're not going to add 150. We're going to add whatever's at 150. It's important to note that 150 is checked at runtime, right? So this value is not known at the time we wrote the program. This value is what happens to be currently held in the HX register as the program evolves. So this little object code F9 up here, you'll notice this is shorter than any other command that we've covered so far. Because what it's doing is it's saying go out there and check the HX register, see what address that points to, and then add whatever's in that location to the accumulator. There's nothing else to know. You just need to know that the HX register exists and check its current value. So then, just to give a concrete example of what's going on, let's say that those HX registers we're sitting here at values of 0150, and then if we look down in memory at that location, so where this is 014F, this is 0150, this is 0151, if this location here had a 5 in it, then this would have the same effect. Running the indexed add would have the same effect as what we've been studying so far. That would add 5 to the accumulator. So if that accumulator, this by the way is H and that's X, if that accumulator had a value of 1 and we ran into an object code, which is F9, if we ran just this little bit of object code, we would see that the value in the accumulator would go to 6. But there's a critical difference in this compared to previous code, and that is that if we then ran a command, so I'm not going to say what that is right now, but let's talk about incx, so that would increase the value of the x by 1. So now instead of 0x150, this is 0x151, and then maybe the next spot in memory has a hex 20 in it. And we then ran F9 again. So the same exact object code as was done there. What it's going to do is going to look at the value of the HX registers. It's going to say that's 151, and then it's going to go grab this 20 instead of that 5. And so then our 6, because it's still a 6, we added 5 to the accumulator earlier, so it's a 6 now. So now that's going to hold a 26. And it's important to recognize that this is a very different outcome despite having identical program command statements. I started this video by saying that we wanted to do things of this form, which is to say we want to add variable elements of an array. And we're most of the way there. To get all the way there, we need to look at a few new things. Specifically, we need to look at a couple of new commands, including the load index register command. So this command is going to go out there, it's going to put stuff into the index register, the HX pair. This, in combination with a little bit of math and a little bit of work, allows us to do this sort of variable lookup. Now for a concrete example of this, let's look at some stuff that I've typed up here. So in this case, imagine that we have something that's conceptually of this form, where we've declared a character array, it has some stuff in it, it's been assigned a spot in memory. And specifically, it's been assigned the first byte to be hex 120. It's worth mentioning that something like this, if you declared it a constant character array, could live in program memory, and the index additions could work out in program memory, and that'd be a really good place for this. But for today, let's consider this to be a RAM location. Then let's think maybe I've got a variable, I have that I want to index into the ith element of this array, and I have the I in my accumulator. Then how would I go about saying, please go get the ith element? Let's imagine that I is equal to 3. So now I want to get the third element there. This is the 0th and the 1st and the 2nd and the 3rd element that we want to get to this. So somehow, some way, we want to get 1, 2, 3 into the HX register. And then having done that, we can simply do a load command in an index mode. Now we haven't talked about load A, but it's a pretty simple command. It just grabs whatever's at that memory location and puts it in the accumulator. So that would take care of reading this value into our accumulator. But how do we get there? Clearly what I want to do is I want to load in something having to do with Z into the HX register. But I don't actually have this character array Z. What I've got is something I've defined in assembly. We haven't talked about what that is yet, but Z is, for all intents and purposes, the start of the array. It's a value that the assembler knows is 120. So I can do things like load A Z, which would say this is 120, and so it would load A with what's at 120. I could even do load A Z plus 3, where Z is 120, so the assembler would add 3 to it, and then at runtime we'd be loading whatever is here in our target spot. But again, I don't want to do this in a set offset way. I want to go ahead and read that based on the value of I at runtime. So this method is no good. Now, I don't want to load HX with Z directly. If I don't put this number sign in here, it will load HX with Z. If you look back at what that is, if you just put a number in there, it's going to be taken to be an extended address, so it's going to load the H and the E in there, and we're going to be looking out in some weird spot, probably in unimplemented memory. We don't want that. We want to load HX with 120. So it's very important that you understand why this is here. It's here to say this is a number I want you to put into the HX register. Okay, but at this point we have HX being 1 and 20 because we've loaded in that value of Z. All we want to do really is we want to add I to this. Unfortunately, we can't do math directly on the X register. So what we're going to do is we're going to transfer the X register into the accumulator. This is going to overwrite that value of 3 that I started the video with saying is there. So that 3 is gone, and now we're left with just the 20 that we've transferred in. And then we're going to add, without carry, probably, we're going to add I in. I's value is 3. Again, this I, that is actually a memory address, but it's going to go out there and read the value because I did not put the immediate or interpret it as a variable. So then this value is going to become 23, which happens to be the address I want to do. Then I could come over here and say I want to transfer that back. I do that with a transfer A to the X, transfer accumulator to the X register. With those three commands, I could make it so that the X register becomes 23, where this this was a variable, right? This is a thing that we do not know at the time that the program was written. It's something we've loaded in from the outside world. And now what I've got is I've got that address here. All I need to do is run that index mode. And then we're there, because since the HX registers point to the location I want to go to, if I run a command in indexed mode, it's going to do what I want to do. Now what I want to do is load it into the accumulator, so load A, and then I have to tell the assembler, hey, I want you to use index mode. It turns out that you just do that by comma X. There is a space here. The space is important. Load A space comma X. Comma X is the operand, says use index mode, or in this case, use the address stored here in the HX register to go out and find the value to load.